This past September, the WebP celebrated a 10th year anniversary. But in the 10 years it's been around, we've not seen the kind of adoption we might have expected. In fact, excluding Chrome, the WebP was made available in stables only since about fall of 2018. But despite all that, 2020 has been a bit of a banner year with a decade in existence and finally Safari coming around for full support with a little bit of a flag. But this comes as newer formats are popping up and showing their wares. So what's next for the WebP? Well, here to walk us through a historical timeline for the format, including what might be a future WebP 2.0, is Pascal Massimino. Enjoy.
Normally you should see my slides, right? I'm sharing the screen. Is it okay?
Yes, we can.
Okay, excellent. A bit of warning, if you see me disappear, it's because I'm very low on battery. I don't know why it dropped. So don't hesitate if I don't surface back to move on to the next speaker. Hopefully it should be okay, but you never know. Yeah, so thanks, so thanks for being here, everybody. And thanks, Henry, for organizing this image-ready talk. 10 years in the making for WebP, it's kind of an anniversary for us. So a bit of context, maybe I'm Pascal. I've been an engineer at Google for a long time already, and yeah, I was kind of working on on the video compression thing on this little company called YouTube. And then around 2009, 10, I realized there was a problem with images, and that's what I'd like to talk about and why I switched to doing image compression at that time. So yeah, let's talk a little bit about WebP, rewind a little bit. So yes, that's kind of it's a big day today, 10 years after, because when you try to see what's the support for WebP on browser, you see there's a lot of green happening. It's not always like this in the past, but now we're kind of reaching the full the full support for WebP, and with Safari 14 coming out, it's almost complete. And so really, it's been quite a ride, and I like to go back and look at the lesson we learned to get there. So yeah, let's go on story time. 2009, I tried to figure out what it was like, the web in 2009. I can tell you it was looking like that. And you can see in 2009 there was a problem coming up at this YouTube page. It was not this massive video 240p, this big flash player, etc. The real problem that we were starting to have at YouTube was this. You know, see all these thumbnail, all these images, all these ads on top. It's a lot of connections to handle. It's a lot of size actually. And it's a joke that YouTube was the #2 image serving site in the world actually because of this. Because when you landed on YouTube, you would have like 20 images to serve. Even if they are not big, that still it counts. Whereas when you're looking at the video, you're just sitting in front of the video, and that's one stream. It's highly cacheable. It's kind of easy to handle. The video part is like the easy part, but the image part was kind of a bit difficult. And it got worse after that because if you remember, YouTube was looking like this in 2010. So a lot of images, and they grew larger and larger. So we had a problem coming with images more than video, surprisingly. But if you remember also in 2008, 9, 10, Google acquired this company called Untitled, and its VP8 codec was kind of pretty efficient and very viable competition for H.264 actually. And he had the nice property to be royalty free. And so yeah, Google released this video codec in 2010, and it was there to stay. It was for video, but I mean it was compressing pixels. So the idea was very simple. We have a problem with the size of images. Let's just wrap the video codec into an image format, and that should be it. It's going to stay anyway. So basically, you have an image codec for free with the VP8 coming up. So that's it. All right, so let's do that. That was the idea at this time. Let's go for it. We had the user's interest in mind. Like it should reduce the size, so it should be okay anyway. So off we go. It's 2010. It's kind of work in progress. And we'll go through all the history from 2010 to 2020. So yeah, 2010, we kind of worked on the codec, trying to wrap it for the Lossy, because VP8 was doing only Lossy compression in a JPEG sense, if you wish. So happens, it's 2011, and then we kind of released the first believable version, and it's shipped in Chrome also and in Android 4.2.0. So things are doing rather well, and we see some good results. We are pretty happy with Gmail, for instance. Things are starting to take off, but still a little bit of missing piece, and this piece came with the help of Opera, actually. That was the first non-Google company to kind of adopt, and I'd like to give a shout out to Opera for this very early support. They were really trying all the technology around all the techno available, and it was very good to have a side ally on this adventure. So we keep going, and it's 2011, 12, and then we added some extra feature because we saw the need for alpha transparency, lossless for also formats. So it's kind of a very unstable time, 2012, because we had several features going on. It's kind of like trying to do PNG, JPEG replacement. So I will come back to that later, but it was a strange time, and errors were made. But eventually, if I fast forward, I'm going to skip a little bit ahead. Fast forward to 2020, you see eventually all the browser ended up supporting WebP. Yeah, it's a good result in itself, and it took its time. And you can see, for instance, that there seems to be not much happening in 2014, 15, etc. But actually, that was the most busiest time we had, because you have to remember that browser is one thing, but there was a lot of services and sites that moved progressively to using WebP, and that was the most important part. So I noted a few of them here: YouTube, Netflix, Facebook tried the app, etc. eBay, all the merchant sites, they saw advantage in WebP reducing the size, etc. So progressively, a lot of sites. Wikipedia was a nice touch also, even Ingol recently. That was the most busiest time we had, actually, 14, 15, 16, etc. So yeah, browser, we are talking a lot about browser support, etc. But really, I like to emphasize that support from the allies, like the one you don't necessarily see on the surface, all the CDNs, the early adopters like Cloudflare, Codinary, Akamai, all the mobile apps. You don't see the traffic for WebP on mobile apps, but it's there underneath. And all the mobile game developers which switch from WebP to from PNG to WebP, sorry, because they saw a very good replacement for PNG using the Lossy WebP with transparency. And last but not least, you have to remember there are also animated format going on, and other formats being adopted by other browsers. So it's been a busy decades actually for all the image formats. So the question is like, was it worth it? Like, was it a good idea eventually? If you take the Lossy case, actually, it was beneficial because when you're downloading a JPEG, you spend a lot of time, especially on the emerging market, on a slow connection. You spend a lot of time transferring, and then you decode quickly. It's very cheap to decode the JPEG. But if you replace that by a WebP, which is slower to decode but transfers faster, you see if you are sufficiently fast to decode, you still have a net win at the end because transfer is smaller, decode is a bit heavier, but yeah, eventually it's less time to render for the user, and statistically we saw an improvement in user engagement, especially since we introduced the incremental WebP, where you kind of combine the transfer with decoding as much as you can as you go. And if you can parallelize this I/O bound process with the CPU bound process of decoding, then all of a sudden you have a much larger benefit in the end for the user. And also something you have to remember, like I took this picture in 2015 in Greece, and you were paying by the gigabyte actually for the data. And even if it was speed neutral in the end, and the battery life was the same, still we were saving like data cost for the user. So even that was enough for it to be worthwhile, literally. If you've ever run out of battery of a data plan in vacation, you know that it can be a pain. And also another takeaway I get from that is that if you remember 2010, the websites were very heavy. Image optimization was not a thing, and people were just dumping their JPEGs and with huge use size. And I think it helps all this discussion about image format optimizing. It helped transitioning from the web we knew to the web we know now, with which is optimized, responsive. Maybe not for all, because if you look at CNN, okay. Anyway, so the lesson, the early lesson we had in this time, like I think that one of the big problems we had for WebP at the beginning was we introduced a lot of features as we were going. Actually, we realized, oh, we need alpha, we need losslessness, so let's put that into the format and as we go. And actually, it was a lot of confusion for the WebP format instead, because you never know when it was WebP, does it mean the Lossy? And since browsers were progressively introducing each features, you couldn't tell exactly what you would get when you were using the MIME type image WebP. So the lesson we take from that is that if we ship feature, we should ship them all at once and not progressively, otherwise it's a bit confusing. But now we know which feature we need. We need alpha, lossless, etc. So that's a good thing. Another lesson, we thought like hardware would be there for a long time, and it would help the decoding of images, but actually it didn't help, because we did some tests, and VPA decoding was only 2 times faster, but then like dealing with the non-parallelizable hardware decoding, like if you land on the Tumblr page with tens of animation to decode in parallel, the hardware we can only take them serially. So that was not very helpful. It's difficult to change the resolution, etc. Lossless, you cannot do it in hardware. So it was not a very big win to expect the hardware to help for images. And that's one of the problems. And remember, the hardware deprecates sometimes faster than software, right? If you have some CD-ROMs at home. But we also had some nice surprises also, because, like I said, the alpha, the transparency as a replacement for the WebP, as a replacement of PNG and games assets, for instance, was a good surprise. And we had a lot of support from the community, because we could experiment with alpha container and made some mistakes and like roll them back. That was not a very big deal, because the development was in the open. So that was a good takeaway from that. And so if I want to finish with an insight look back actually on this idea of taking a video codec and trying to make it into image codec, and why it was a half win actually. So you know, history is repeating itself with HEIF and EVIF starting from a video codec. So I'd like to take a moment to look back at all the work digitized from starting from 2010. So in 2010, you had the JPEG format was the format for everything, image, photo. It was all JPEG, and PNG also and GIFs were there, but it was mostly JPEG. And as we went through time to the 2020 now, I think it has moved to 2 use cases actually, and one is like the capture, what I call the capture use case, where JPEG is very useful. You want some very large, high-quality image, and you want to send them to a server as fast as possible, etc. So that's kind of the capture use case, and JPEG and video codec can be useful there. But then I think it consolidated also the JPEG plus PNG plus GIF into what I call the web use case, when you're just casually downloading images, browsing your Instagram feed, etc. You don't necessarily care about large resolution, high quality. And I think that's where the WebP kind of unified all these formats into this single use case of the web consumption, actually. But we still left with the capture use case, which is very, very important. You want to take picture as fast as possible. So that's where the modern codec can still be useful. But I really think it's a different use case. We didn't realize that in the beginning when the world was evolving, also as we were going. But I think that's the current state of affairs, and we should really keep that in mind, actually. So there are, and also the conclusion is like there are some features that you need for an image codec that you don't find in a video codec, like transparency, which is always a human intervention. You don't have any device to capture the transparency. Losslessness, which is most useful for video, and everything like thumbnail, interruptibility, and animation, which is kind of different from video. So yeah, that was my main takeaway from this video versus image codec. And to finish with, I'd like to reflect back on the problem of deploying at scale, actually. As they used to say that the hardest part is the first billion user, then it gets easier after that. And but in terms of security, binary size, releases, everything, adding features, you have to manage a lot of users, and that's always a difficulty. But my takeaway is that you really have to keep things simple and useful. Like if a feature is not useful to 95% of your users, it's just like exposing yourself to trouble. And we had to cut down on some features, because the more you add flexibility, the more liability it gets. The format is complicated, etc. You have security issues. So keeping it simple, and it's always a good thing and useful, of course. And of course, we had a lot of help from the community. That was one of the strong points for the LibWebP, where it was like royalty-free, of course, open source, and what I call bulletproof. It was not an experimental or a reference code. It was the code we were shipping in Chrome, and it was very robust, and it helped a lot in self-serving, actually. People were just picking up LibWebP, trying to use it. It was kind of working for their use case, and they were happy. And we didn't have to do anything past 2015, let's say. People were just using the LibWebP. It was everywhere. It was known as being the library that can sustain billions of users. So that was a very good selling point. And I'd like to thank all the contributors. I'm just listing the author file from the LibWebP. So all these contributors just like helping with obscure platform compiler, mainframe, IBM not working, etc. It helps a lot in the long run, actually. All these little bits, they count. So thanks to everyone. And this is the end. Or is it? I mean, it's been 10 years, and since 10 years, the technology has evolved a lot. And there's still a lot we could do, actually, to push WebP further, and the second version, more of the same, but with all the same principle. I mean, the world has changed, and it's more than ever very important to keep the resource in mind and try to lower the consumption of data, etc. And also, like, it has evolved in terms of tooling. We have the service workers, the WASM, like in the Squoosh case, to help us like try to deploy some codec without having to ship them in binary formats. So if we don't rely on hardware, there's certainly some things to do and to try here. So I'd like to take a quick look at what we are working on and some kind of ideas and next feature we could use for WebP V2 while keeping it simple and useful as usual. So first thing is we have to deal with is it's HDR. And it is my, I think that 10-bit should cover all the use case we were lacking for WebP V1. So it helps the compressibility also. So yeah, let's go 10-bit HDR should be very beneficial. We had also some ideas like not using the regular color space like the YCBCR that everybody is using, and we could use some custom-made color space for particular images. Because, for instance, if you have this kind of image of very colorful and very skewed distribution of color, you certainly you can try to find a matrix that's for the color space that is better fit than just the regular one. And I mean, this image is a little bit twisted, but it's quite frequent that you have some images that could use some custom color space transform because they are pretty skewed in the colors. So it's useful. We tried and it's useful. For entropy coding, ANS is the next thing to use because it's very compared to Huffman coding, it's very practical and software friendly, etc. So let's go for it. Fully incremental and suspendable codecs, very important for image, less so for video coding. Basically, you just say that when you fetch the next byte, the codec doesn't know it, but it can exit actually, fetch on the network, and then come back to finish decoding the image. So you don't have to stop to store the state of the codec and restart the decoding, etc. Just suspend the process using coroutines, and then resume the process, and there you go. That's less memory, less CPU, all good. We had this idea also of like using arbitrary block layout and not using this fixed block that's traditional with codecs. And so how can you do what I call the floating partitioning, when you can use any position for the blocks? We use the multipass actually, where we start with the big blocks first, the flat area, and then we refine progressively the partitioning with the blocks that have the same orientation. For instance, they're going to be well predicted, and then we fill up with the one that have the same variance, for instance, and then we end up with filling the gaps with the small 4x4 blocks, and then you get a very nice partitioning that fits the natural geometry, and hopefully will lower the size you use for residual coding. And then you can also exploit the fact that you don't have to code the blocks in lexicographic order, but you can decouple the parsing order with the decoding order. For instance, you can try to maximize the availability of the samples on the left of the block for a better prediction. So you have this strange decoding order. It works also. And of course, you can borrow all the new tools from AV1 and AV2. The transform, they are the same, the residual coding, all the filtering, etc. I mean, there's no reason not to use them for image coding, these particular building blocks. For lossless, the same, but more of them, of course. And for the alpha transparency, there's more we could do for V2, because using Lossy on this innocent image, for instance, is very useful, because when you look at the alpha mask, it's very well compressed lossily, because there's a lot of anti-aliasing going on, etc. So using lossless for that kind of alpha mask is not useful. Lossy is better for that. We have this idea also of mixing the lossy and lossless modes, because if you take this Wikipedia page, there is a combination of photos and text, and you could use lossy for the photos and lossless for the text. And actually, it works pretty well. Also, we don't have to go full progressive. We could use preview funnel, that's the fourth main progressive, because in 300 bytes you can fit a lot of semantics. It's kind of semantic compression. So we have this we have this technology for previewing with triangle. And if you squint a little bit, in 3, 2, 1, up there, you can see it fits pretty well as a preview for the final image. You can see the triangle on the lower right. And the decoder is only 300 lines of WebGL with triangles. It's pretty easy. So there you go. Surma did a demo about with WebP V2, thanks to the WASM power, as I said. With WASM, you can try codecs. So if you look at the JPEG and WebP traditional low bitrate operating point, like 0.37 bit per pixel is very low. And you can see the bending and all the artifacts showing off. And with AVIF or WebP V2, you see that we still have some better quality at this low bitrate. And like it's even more prominent for fine details, like the shot of these guys, which gets very mushy on low bitrate with WebP JPEG, but gets much better with AVIF or WebP V2. So for the same size, we could get a much better quality on the low bitrate side of the spectrum. And so, yeah, that's all sort of good ideas for WebP V2. I guess we just have to go. So it takes 10 years to get there, or maybe shorter, maybe next week. Actually, it's not impossible. I'm able to release the code tree for WebP V2. We've been working on the next week, or maybe in the coming week. So we really like people to try it out and get some feedback about all these ideas and what could be the WebP V2 formats. And I think that's it for good this time. And if you have any question, of course, please